12.7 notes are solving exponential equations. So at this point, we've solved logarithms, and we talked about how you only have two options. Either you have the logs on both sides where you can drop them, or you have one logarithm that you then change to exponential by loop swooping and then solving from there. So that's the same thing, it's just in an exponential format. So here's what this looks like. Option 1, which complements the logs on both sides, would be when you have the same base is on both sides, like that very first example right here. Well, hopefully it's obvious without having to do any math at all that x has to equal 5. It's got to. If 3 to the x equals 3 to the 5th, clearly x equals 5. So since the bases were a match, did you even need them in the first place? No. If the bases are a match, you get to drop the base and solve whatever's left over. That might mean SAD mapping, it might mean factoring, it's just whatever it's going to take. Option 2 is when you can't make the bases the same, like 3 to the x equals 10. There's nothing I can do to connect 3 and 10. If I can't make the bases the same, and you're in BF format, you will turn it to Bay. You will do the opposite of loop swoop. Instead of going from log to exponential, you'll go from exponential to log. And that means that you would have a base of 3. Remember, because log is Bay, base, answer equals an exponent. The answer is 10, and the exponent is your unknown. So for these examples, it should be really simple because you would have to have a calculator to solve them, to solve that log base 3 of 10. And then you tell me whatever that number is, that decimal, etc. So your biggest issue is going to be, can you make the bases the same? And I need you to look for taking the bigger number. I don't mean if it's a fraction, I mean like in this case the 9, and writing it to the smaller. See, you can't take this 2 and turn it into 4 because you'd have to square to get it, and if you square one side, the rules of math tell you got to square the other side. So you'd never catch up because this would become a 4 and this would become a 16. Again, they're not a match. So you can't make the smaller and turn it into the bigger. You can take the bigger and turn it into the smaller. And when I say bigger, I don't mean the fraction, I mean the big number in it. 9 versus 3, 9's bigger. I can write that as a version of 3. Speaking of, so 3 to the x, I have no way of changing that. I can't change what the base is. I can't manipulate that. What I can do is the 1/9 I can turn into 3 to the second. Isn't 3 to the negative second 1 over 3 squared, which is 1/9? Yeah, it is. So if 1/9 is really 3 to the negative second, and you already have this x plus 3 that your base is being raised to, you now have a power to a power. A power to a power, you multiply the powers. Since our bases are the same, this is option 1, where we get to drop the bases. So x equals negative 2x minus 6. Well, if x equals negative 2x minus 6, I would need to, that's a 2, I need to add 2 x's. So 3x equals negative 6, divide by 3, x equals negative 2. This is actually really easy to check, which is nice. You can just plug it in. 3 to the negative 2 is supposed to equal 1/9 to the negative 2 plus 3. Well, as we already talked about, 3 to the negative second is 1 over 3 squared, which is 1/9. And on the right-hand side, negative 2 plus 3 is positive 1. So is 1/9 equal to 1/9 to the first? Yes, it is. That checks out. Okay, let's see if you caught on. I can't take the smaller base and make it bigger, but I can take the bigger and make it into a version of the smaller. Or I can see what they both have in common to then root back down to that. So 2 to the x minus 2 isn't going to go anywhere. 4 is going to become 2 squared, And because I have 4 to the x plus 1, I really have 2 squared to the x plus 1. A power to a power, you multiply the powers. So 2 to the x minus 2 equals 2 to the 2x plus 2. Bases are the same, drop the base. X minus 2 equals 2x plus 2. SADMAP skills kick in. Subtract x. Negative 2 equals x plus 2. Subtract 2. X equals negative 4. Let's check it. When I plug in a negative 4, I have 2 to the negative 6th, negative 4 minus 2. When I plug in a negative 4 here, negative 4 plus 1 is negative 3. 4 to the negative third is 1 over 4 to the third, and 1 over 4 is, 4 to the third, is 64. 2 to the negative 6th is 2 to the positive 6 on the bottom, so 1 over 2 to the 6th, and 2 times itself 6 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, that's to the 5th, and to the 6th, one more round, times 2 is in fact 64. Negative 4 checks out. So at number 4, you have an option where they don't match. And it's not like you can just take the 4 and turn it into a version of the 2. 32 can't become 4, not when using exponents. However, you can see that they both can change. 2 squared is 4. And I just mentioned that 2 to the 5th is 32. Bases match. Drop the base. 2x minus 2 equals 5x plus 10. Let me get this out of the way. I'm going to subtract 2x. Negative 2 equals 3x plus 10. Subtract 10. Divide by 3. Coincidentally, x also equals negative 4. Different equation, different x, still a negative 4. Okay, quick check. Negative 4 minus 1 is negative 5. Negative 4 plus 2 is negative 2. Is 1 over 4 to the 5th the same thing as 1 over 32 squared? I do not have that memorized off the top of my head, so I'm going to do 4 to the 5th on my calculator real quick. Four to the 5th, 1024. 32 to the 2nd, 1024. So yeah, 1 over 4 to the 5th is the equivalent to 1 over 32 to the 2nd. It's 1 over 1024 equals 1 over 1024. Okay, number 5. How are you going to connect 1/100th and the square root of 10? Now, it's not about the fraction. It's about the number that is in the fraction. 100 is bigger. I can make 100 into 10 squared, but that's in the denominator. So instead, I will do 10 to the negative 2nd. 10 to the negative 2nd is 1/100th. So this is being raised to the x. So I've got 10 to the negative 2nd raised to the x. So I've got 10 to the negative 2x. 10 with the square root. Remember, a square root is to the 1/2 power. I did that like really ugly. From unit 7 or 8, 7 and 8, x to the 1/2 power is the same thing as square root of x. So this base, square rooted, that is 10 to the 1/2 power. Now we are raising that to the 6x minus 4. Drop the bases because they're the same. So negative 2x equals half of 6x's is 3x's. Half of negative 4 is negative 2. I'm going to subtract 3x. So negative 5x equals negative 2. I'm going to divide by negative 5. So x equals positive 2/5. It is totally okay for you to get a fraction. It's totally okay for you to get a negative. Exponentials, there's not a big round of restrictions. You're totally fine either way. Now, I'm going to check this in the calculator, and I'm going to remind you that you actually have the ability to check in the calculator by using your test feature, whether you're on an 84 or an Inspire. So for time's sake, I'm going to quickly store in 2/5 in for x. Boom, x is 2/5. And then I'm going to test. Control divide makes my cute little stacked fraction. I have 1 over 100, and I am raising that to the x. Does that equal, arrow to the right, excuse me, and then my next fraction, oh, it wasn't a fraction, excuse me, gotta look ahead. Square root, control x to the second, 10, and then that is being raised to the 6x minus 4. True. So 2/5 works beautifully. Nice. Remember that if you're on 84, it'll give you a 1 for true, a 0 for false, or an error also means false, like extraneous. So we're good. Okay, last 3 questions. Quick and easy. This is option 2. In the beginning of the lesson, we talked about how the bases needed to be the same for you to be able to drop it, but that sometimes you can't make them the same. There's no connection between a base and an exponent from on each side. Like 9 and 35. I cannot take 35 and make that 3 squared or 3 to the third or 3 to the fourth. It doesn't work that way. So all you have to do, if you can't drop the base, you just change it to logarithmic form and you let the calculator evaluate it for you. You are in BIA. A base to an exponent equals an answer. Log is bay. So our base is 9. Our answer is 35. Base is 9. Answer is 35. Our exponent is x. The calculator does the work. Oh my gosh, I'm so tired, y'all. I'm so sorry. The calculator does your work for you. So we're going to, let's see, control 10 to the x. Type in 9 and 35. It is totally fine that your calculator approximated it for you. 1.618. Good enough. 3 places is plenty. 3 places is actually the norm. Now, if you want to check it to make sure you did it right, what you're saying is 9 to the control negative takes that answer you just put in, and that should equal 35. I'm plugging into the original problem. 35. See, see, they rounded it for you as well. What am I doing? Go up that way. Oh my goodness. Sorry, y'all. Okay. 2 more. You might think that you can connect 15 and 30. Nope, not through exponents. Yes, 15 is half of 30. Yes, 30 is twice 15. That is not using a base and a power. So there's no connection here. So we have a base, 15, an exponent, x plus 3, and an answer, 30. Convert to logarithmic form. base 15, answer 30, and your exponent is x plus 3. Calculator does this part, and that will equal x plus 3. So then all we will have to do is subtract 3 from the other side to get x by itself. So in comes the calculator. Log. And an 84, I believe that's math alpha math. 15 is the base, 30 is the answer. That gives us 1.25596 as an exponent. 1.255 or 56 if you round it. And now I'm going to simply subtract 3. Answer minus 3. So my answer is negative 1.744. And again, if you type this exactly as you see it, in the original problem we would have 15 to the answer plus 3, and it should be equaling 30. Ta-da! These are fun. These are easy. So negative 1.744 because you subtracted 3 to get x by itself. Totally works out. Last one. 7 and 70. Again, we can't connect them. You're in BIA, your base, your exponent, your answer. Convert to Bay. Log base 7 of 70, your answer, equals your exponent of 2x minus 5. So we find this out, and then we will add 5 and divide by 2. I don't know why I just did that. That's the worst. It's late. I'm so sorry. No, it's not. It's not even late. It's 4:44 p.m. Oh my gosh, I'm so tired. I'm so sorry. All right, I'm still powering through. It's the last one. If you're watching this video and you have actually watched like all 7 of these videos, I'm impressed, and I'm hopeful that I am coherent, as the longer I make these, the more tired I get. It's been a long road. Log base 7 of 70 is 2.18329. 2.18329. I will then add 5. So 2x equals 7.18329. And I will divide, that's a 2, by 2. So I will add 5 and divide. Nope, I need to divide. Escape. Divide is that one, by 2. So my answer is 3.592. I round it 3 places, 3.592. Okay, and again, I can check that with the calculator. I can just plug that right back in to my original using the answer function. So we've got 7 to the, and it looks like I've got 2 times the answer, and I could have stored that answer in. I could have done that also and just used the x. Either one works. Minus 5. That's all in the numerator. That should equal 70. Ta-da! All right, if you have bared with me this far, congratulations, and thank you so much for your patience. Good luck. I hope you guys are doing great. I'm sure you are.